I just always. That's why I write the shit down. It's always going to come out the same way. All right, now you got to work with that. Is that what you guys got for in there eventually? And then, all right, what happens here? And of course, the limit of this is 1. So that 3x has to be less than 1. Now, if you always get the x piece with the 1 coefficient, you can see the radius here. So if I divide by 3, which is legal, because 3 is positive, so it's not going to do anything with the inequality. So now I get negative 1/3 less than x less than 1. Now, hopefully somebody could see that from the beginning. The reason this thing would grow like crazy is because of that 3 to the n term. So if this is big enough, if this is enough to kill this, so it's got to be 1/3, 1/4, 1/5. I mean that will kill this. Does that kind of make sense? I'm not saying you have to be able to get the answer straight from here, but you can see that it makes sense with what it was. That 1/3 will kill that 3 to the n. 1/4 would overkill it. Does that make? Do you guess? Maybe I'm not. I accept that sometimes it makes 0 sense. Now I have to check the endpoints. So if I put in there a negative 1/3, can you guys see that it's going to result in a negative 1 to the n on the top? So if I do negative 1/3, I get negative 1 to the n over, well, that's not very good, Jeff. Check x equal to negative 1/3. So you get negative 1 to the n over n plus 1, and of course that. Well, because of this, it's saved. That converges because it's alternating series that goes and that the limit goes to 0. So that converges. But 1/3 would not have the alternating piece, so that will not converge. So I always say the more you know, the less you have to do, but you still have to say, so if on the test you did this, and you said converges, and then you said, so 1/3 leads to 1 over n plus 1 diverges. Kick ass. All right, I love it. You shouldn't have to write a lot if you understand what the hell's going on. Where'd it go? N plus 1. Boom. All right, is that cool? All right, so what about this guy? I'm going to put the x over there. So that becomes... All right, you guys just aren't going to help me. That's all right. I'll accept that too. What do you get on the bottom?
2n plus 3.
2n plus 3. I like it. If you replace n with n plus 1, the 2 distributes. 2n plus 2 plus 1 is 2n plus 3. Oh, shit. And of course, that would throw everything off. Because here now, you're going to have this reciprocated, so you're going to have 2n plus 1 factorial over, poor little x, dude, over n squared. So this limit here is 1, because they have the same degree. Now here, which one do I shuck stuff off of?
Top 1 plus 3.
The bottom one, because it's bigger. So it's gone a few terms out. So I could take a few terms off of it and make it the same as that one. So now I've got 2n plus 1 factorial over 2n plus 3, 2n plus 2, 2n plus 1 factorial. So that goes away. And what's this limit? Which is always less than 1, so the interval of convergence is, the radius of a convergence is infinity. It's not infinity divided by 2, that would be an evil. I want somebody to say that. Cut infinity in half. All right. All right. So this one, now that you see how that piece works, I want to throw a few factorials at you. So here I get, on the top I get 2n. You guys see how, since that's a 2 multiplier, it's going to go up by 2? If it was a 3 multiplier, it's going to go up by 3. All right. 2n plus 1 factorial over n plus 2 factorial times n plus 1 factorial over 2n minus 1 factorial. And the x stuff, I'm not even going to write it, it's just going to end up being one of them. All right, let me make sure, please, dear God, there's something I'm doing, you're not sure where it's coming from, tell me now. I'm kind of introducing some shortcuts. Why keep writing the x stuff when it's always going to be offset by 1, there's going to be one of them left? Yes?
So that's why you didn't write the n for the x minus 2?
Beautiful, because it's always going to be x, the x piece to the n plus 1 divided by the x piece to the n. So you're always going to be left with one of them, because we're dealing with power series, which needs the x to be on top to the nth power. Right? You could have general series where the x can actually be wherever the hell it wants to be. But right now we're talking about power series. So what do you get here? So here, you can work with this guy. And then here, you can work with this guy. So that these cancel. And then you got your x minus 2. So you get the limit, n goes to infinity, of 2n plus 1 times 2n over n plus 2. Sorry. This is the other case. So here's all three cases. Finite radius, infinite radius. And this is like the opposite of infinite. This is like greater than 0 radius, let me say that. Greater than 0 radius, which is still infinite. And then this is the third situation. The limit of this is always what except for one time? What's the limit of this piece? Infinity. But, now this is where you guys have got to realize, this is not an indeterminate form, because if x is what, the answer is 0. If x is 2, then I don't give a shit what this guy does, because every term will be 0. 0 times small n stuff, 0 times bigger n is always 0. It's not 0 times infinity, indeterminate, whatever. It isn't, because they're not both going somewhere. This one would be 0. It's there. It got there. Right? It's not approaching it. It's there. Do you see the difference why some things are indeterminate? Because they don't get to 0. And this doesn't get to infinity. So then who gets there faster? Blah, blah, you know. This is like, I'm there. Where are you at? All right, you're dead. All right. So x equals 2. What kind of radius would this be? 0. 0 radius. You're just a point in the center. You're on the center. So 0 radius. So it only converges if x is 2. So there's nothing to check. And this is kind of like trivial convergence, right? If x is 2, the series is 0. Yay. Good job, us. Okay. I want to show you the three main things that could happen. Did you guys get a chance to do number 2 yet? Leave that up here for a minute. Number 2 should be a little quick if you got my point from earlier.
So can we state an interval for C, or is that?
No, not really. I mean, it's just 2. I mean, there's really no interval to. So you could say like 2 less than or equal to x less than or equal to 2, which is kind of like being just silly, to be honest. Just say x is 2. You could say r equals 0, 0 radius. So this is make this a little more comfortable maybe. Let's say y equals that. So then y prime, if you didn't do this, it's not a big deal. Just list the derivatives. How do I take this guy's derivative? Worry about the inside first. What happens in there?
1/3.
Yeah, the n comes down, so it cancels that n. So now it's x to the n minus 1. Now, since this didn't start at 0, you gotta be careful. Is n equal 1 still valid?
No.
So let's see. Now watch.
2.
What are the elements of this one? What are the elements of this one? This would be, if n is 1, I get 1/3 x plus, who gives a shit? Because if n is 1 here, what would this guy's derivative be?
0.
1/3.
1/3. And if you leave n equals 1, what's the very first thing you get? 1/3. Oh shit, then it better stay at 1, right? So that n doesn't always change. It's just because when it's 0, it does lead to a little bit of weirdness. That's why we can shuck that off. We can forget about it because it doesn't give us anything. If it's not 0, it doesn't necessarily do that kind of thing. You gotta be careful. So what about the second derivative? Let's work with this inside first. And now, would it be wrong to say equals 1? No, but what do you get when you let n equal 1? You get 0. So you might as well start at 2. But part of you should be like, oh, thank God. I can't remember if in 280 you did any derivatives of series. I don't think you did. But they really are just applying the rules, to be honest. It's kind of nice. Here comes the more interesting stuff. I'll use that adjective. The stuff related to number 3 down there. We're actually going to, as a result of solving DEs, we will get expressions like these. And then we will set up recursion relations to figure out what the constants are. There won't be an infinite number of constants. They'll all be related to maybe 2 of the constants. Like maybe C3 will equal negative C1 and C4 will equal 5C2. You know, they'll all be related to 2 earlier ones. But we're not there yet. Let's just deal with how the hell to combine those. So just to give you an idea, I can't stop doing this, I'm sorry. If I have a guess for what something looks like and I plug it in to a DE that's equal to 0, then this would be maybe the first derivative, and that would be the thing equals 0. And if I can combine those 2 series, I can then look at the coefficient. There will just be one coefficient expression, and I can work with that. So that's why we need to be able to do this. Now, when I do derivatives, these change, which make them not like terms, and these change, which makes me not able to put those together. So those are 2 things that we have to address before we can combine these. So what is it that we want to do first? Well, I'll show you. I'll do A and then I'll let you guys do B. No, Jeff, don't go over there. There you go. Stuff from the next problem in there. The most important, the first thing you do, the most important thing, I'm trying to add things, and I cannot add things unless they are like terms. That is the first thing you do. And then you try to make the indices the same, and that's an easy one. You just pull off terms until the indices are the same. So if 1 is 2 and the other one's 3, you pull a term off of this guy, and now it starts at 3, so now you can combine them. So make those the same. So how the hell do I do that? And by the way, I don't know why I have x to the k down there. I think I stole this from somebody and rewrote it for myself. I never bring k into this, to be honest. If you're a purist, you guys ever done math induction? And you know that step where you got to make k and all that kind of shit? I'm like, I never did that shit. I'm like, it doesn't really matter. It sort of does, but not really. So this is a situation a little bit like that. I think I kind of gave you an idea of where this is going to go. So the main thing is I want both of these to be x to the n. To be completely honest, it almost doesn't matter as long as they're the same, but it gives you a target to shoot for always. Try to make them both x to the n. So how in the world do I do that? I can't accomplish that by pulling terms off because the form won't change. So what I do is I reset the beginning point. So there's a couple ways to kind of keep yourself in tune. When I put a 2 in, what do I get up here? 0. So can't I, if I want x to the n, then I want to start at, no, come on now. 0. You better get the same thing for the first term, right? What's the first power? 0. So whatever the hell you do, the first power better be 0, or else you've changed it. All right. So I'm going to start at 0 now. Well, now, what does that mean for everybody else?
Change.
So here the first thing was,
So before?
so when I put a 2 in here, I got a 2 here, right? So now it better be, so I'm going to put a 0 in, but I still better get a 2 out here. So now it's going to be n plus 2. So another way to look at it now, you guys realize now that I'm just letting n go to n plus 2. If n is 2, if n starts at 2, n plus 2 would start at 0. And that's why they bring the k's in, because that looks a little bit weird. That's sort of like using goto in a computer program. If any of you guys do in your computer program. Anyway. So there's a couple different ways to look at this. If I let n go to n plus 2, doesn't this become n? What's n plus 2 minus 2? N. So I'm going to replace n with n plus 2. So now what does this become then? N plus what? I like it. I left my CNs out. So this is now going to be C sub n plus 2. I got to make all the n's 2 bigger to overcome that minus 2 that's happening to my poor power on the x. That's another way to look at it. So you guys, what happens to this one, then if I'll make this x to the n, I've got to replace all my n's with
Negative 1?
n minus 1.
n minus 1. So now what? I had to replace all my n's up here with n plus 2, but do you see how that made this start at 0? Because if n plus 2 equals 2, n equals 0. So here I'm going to replace all my n's with n minus 1. n minus 1 equals 0 means n equals 1. And you've got all these checks and balances. If I put a 0 in, I get a what power here? 1. If I put a 1 in, I get a 1 power. Hey, I'm on the right track. So it's checks and balances to make sure that you're doing things the right way. Because your brain can very easily go, let's go that way instead of that way. So this will be C sub n minus 1. I like it. Now, they are like terms, but they have another level problem. What's that next problem they have? The indices aren't the same, right? So the way to take care of that is you take the lower one. That's the one that's got more terms. Why is it weird to say more terms? Because they both have infinite terms. So this has one more term. You guys see that? All right. Or it's offset by 1, whatever the hell. So let me chuck one term off. So what's the 0? If n is 0, what does that term look like? 2 times 1 times C sub 2 x to the 0. Plus, now the next one would be the n equals 1 term. But I don't want to shuck any more off. If that was n equals 7, I'd have to do the 0, 1, 2, 3, 4, 5, 6, and then I can just say sum n equals 7. But here I just took the 0 with 1 off. Now it's going to start at 1. Because I already did the 0 with 1. Yes?
Just double checking, so that's just for that first, the n plus 2 then? That's what you're trying to remove, right?
No. I'm trying to make that become 1. That's it. So what am I going to do to accomplish that? I'm going to plug a 0 in, because now this thing can start at 1. Now the thing is, does anything inside here change? Hell no. That is the definition of the function of n. It's not going to change just because I evaluated one of them. When you do an XY table, plug a 1 in, does the function change now because you plugged a 1 in? No. So it doesn't change just because I plugged a 0 in. It's still the same shit. Keep forgetting my low infinities. Now I can add these. And that really just means take an x to the n out at the end, right? So this will be 4c2 plus sum n equals 1 to infinity, parentheses, 2n plus 2, n plus 1, c sub n plus 2, plus c sub n minus 1 times x to the n. You guys see that? That plus that, I can factor next to the n out. Now I can, because I made all my terms. Okay, that's crazy. What time is it? Holy shit. Well, shit. Can you guys see? Well, let's see. Do you want to try to B, or do you want to try it on your own? Bring it back next time. I'm cool with it. It's been a long ass day. Or do you want to try B right now?
Yeah.
Okay, do it. Try 3B.
So just making sure, the reason we're able to do 1 is because the initial one starts at 0.
Yeah, and I
So
can't.
it's 0 plus 1 plus, and then your function is function at this point, right? So we can, it works in this case. So we can add the n plus 1 to pretty much get rid of the 0, so the 0 doesn't matter. For the actual summations are not summations.
Well, no. So real quick, if I had this. Just look at this. This is 2c0 plus 2c1 plus 2c2 forever, right?
Yeah.
But if I take 2c0 out, that means that everything left would now start at 1. That's it. That's it. So if I take the 0th term, plugging a 0 in, if I take that term and write it by itself, then I can write the rest of the infinite terms starting at 1. Because I've already looked at the 0 one.
Okay, so
Yeah,
now we're just
that's
doing
it.
that first term,
Yeah.
or second or
To
third.
make the indices the same. So I always take the lower one, take enough stuff off so it matches with the other one, and now you're legally allowed to put them together.
I just don't get why it doesn't change your summations.
Why, what doesn't change? Oh,
That's what I'm lost on. So instead of going,
like here. How did I, all right. Let me make one that's a little more interesting.
let's make it real simple.
N plus 1, Cn, x to the n minus, well, let's say x to the n plus 2.
Okay.
All right. Can you start writing the first few terms for me? What would the first term look like?
So the CPN,
Who? First term would involve letting n equal
0.
0.
Yeah. CPN x to the,
What is n for the first term?
Oh,
0.
zero,
So
yeah.
c, 0,
yeah,
because that's 1. X to the
2.
2. Now what's the next term going to look like?
That'd just be 2, C to the 1, x to the third.
Did this change?
No, okay.
No. That's it. So
So in other words, you just shifted everything over.
yeah, I'm
Got it.
I'm doing the first element in the n
I had a brain fart, I got it.
n thingy table. It doesn't change the function I'm plugging into. Let's see. 2. Yeah, okay. And here. Push 3. Yeah, good. And that is 2, I like it. Yeah. And now you just have to, you take the lower one, yeah, and take one term off. I like it. Perfect. Okay, let's see. I don't think you guys have ever done this before. Is that true? Has anybody ever done this kind of thing before? Is it very difficult? No, not really. The way I was taught it, holy shit. But I love it. This is just 2 things to worry about. 2 skills. What's the more important one to do first? Like frickin' terms, because that's the most important thing with addition. Anyway, sorry. Just think back to past Jeff with his teacher. All right. All right, so first thing is like terms. You know, how do I make this become x to the n?
N plus 4.
N plus 1.
You have 3.
So then n starts now at 2. So this will be n plus 1, c sub n plus 1, x to the n. There are a lot of different ways to look at it, and they all kind of check and balance each other. All right, what I do here, n minus 2. So now this is going to become, it's going to start at 3. And it really is just n minus 2 equals 1, solve for n. N equals 3. So this becomes n plus 1, c sub 2, x to the n. Now which one do I use to take a term off? First one, because it's the one that has more terms, but I like looking at it that way even though it's wrong. It's a useful way to look at it. So when I plug a 2 in, I get 3c3 x to the second. And now I can put these together starting at 3. So this would be n plus 1, cn plus 1, plus 2, n plus 1, cn minus 2. Take the x to the n out. Because the next thing would be you equal this to 0. That means that this has to equal this. You can set up a recursion relation between the two. That's going to be a little bit new, just to give you an idea where we would go next. Okay. I think that's enough then. Right. Yeah, that's definitely enough. Okay. All right. So if I were you, I would read ahead into 6.2.